Okay, so let's say I'm given a case like this. It's going to be an ambiguous case. Now, how do I know it's an ambiguous case? Because it always occurs when you're given two sides and an angle opposite to one of the sides. Oh, man. Well, how am I going to remember that? Real simple. Because look at the question. It says, to the nearest centimeter, determine the two possible lengths. Automatically, as soon as you see two possible lengths in the question, or if you got an A, B, C, D multiple choice question and it gives you two lengths, you know automatically it's ambiguous case. All right, so let's solve this. Angle A, 52 degrees. That's 52. Okay? Side B. Well, there's B. Side B is got to be over here. That's side B. That's 12. And then side A is 10. Okay, well, that's over here. That's got to be 10. And now, how is this ambiguous case? It occurs when two sides and the angle opposite to one of the sides is given. Okay, look, there's the two sides, and the angle opposite is given. That's an ambiguous case right there. Okay, now, wait a second. I'm confused here. I don't really like the way this is set up because I learned how to do this with the meteorologist over here, the balloon being up here like this, and the tornado being up here. Well, wait a second. All you got to do is flip this equation around. Flip the triangle around. Make it look like the same. Okay, so watch. Here we go. Watch. Da-da-da. Da-da-da-da. There's our meteorologist. Perfect. Okay. With the meteorologist, it's 52 degrees. Okay, 52 degrees. So the angle always goes with the good old meteorologist. Opposite of that angle is 10. Okay, 10. And then remember this guy over here, which is 12. How do you know? Because that's 12. There's the angle of 52. Goes to the balloon. Boom. That's 12. Okay? All you have to do is rewrite it. And then when you rewrite it, this becomes super, super easy. So let me show you a trick now. The trick is you're going to use this ratio, not once, not twice, but 3 times. So write it out 3 times. You ready? Okay. Sine of 52 over 10 once. Sine of 52 over 10 twice. And sine of 52 over 10 3 times. You're going to use it 3 times. The first time you're going to use this, you're going to find out this angle, right? This is the angle of the tornado, right? Okay, so that angle goes with 12, okay? So sine of the tornado angle goes with 12. Solving this out, cross multiply, that would be 12 times sine 52 over 10, and then don't forget that works out to be sine t. You have to inverse sine to find it. Booting up my calculator, looking at the values again, I got 12 times sine 52 over 10. Okay, 12 times sine of 52 divided by 10. Boom. I got 0.9456. And remember, we have to inverse sine this guy, right? Okay, give me an answer of 71 degrees. So this guy's actually, the tornado is at 71 degrees. That's him right here, 71 degrees. Okay, now let's find this angle. Do you remember how to do that? Sure, of course you do. That's going to be 52, 71 added together, subtracted from 180. Okay, so let's do that. 180 minus the original angle, which was 52, added to our new angle of 71. And remember, I have it on my calculator, so I could just use it there. So let's bring up the calculator. Boom. 180, subtract, bracket, the 52, added to this angle right here. Okay. Gives me 56.98 is our new angle. 56.98, right? That's this guy up here. 56.98 degrees. Now, sine again. But now this goes with this, and we can find our first distance. Yay! Okay, so look how we do it. This goes with this. Again, I already wrote it down. Remember, I wrote it down 3 times. goes with the sine of this 5698, right, over our distance from meteorologist to tornado. There's meteorologist to tornado 1. Okay, cross multiply again. 10 times that divided by sine 52. So meteorologist tornado 1 is 10 times the sine of 5698 divided by sine 52. Okay, so here we go. Let's do it. Calculator. All right, 10 times the sine. Ah, I got it right here. Perfect. Enter. Boom. Right? Hit enter. Divided by, what was it again? Divided by the sine of 52. Oh, okay. Divided by the sine of 52. Divided by sine 52. And guess what? Boom. I get 10.64. That's the first distance, 10.64. Okay, so this is now 10.64. We can figure this out. Everything's happy. Yahoo, Yahoo. 10.64. Now, 10.64 what? Remember your distance all the way back here was in centimeters. So in this case, it is now centimeters. There's your first distance. Now, remember, we're dealing with the ambiguous case. Ambiguous case means that there's our meteorologist, right? There's our balloon. We said that this was at a height or at an angle of 52 degrees, right? And then we did this. We took this side here and we moved it over here. Okay, meaning that these two angles, this one and this one, so the one I found here at 5698, okay, right? Oh, no, wait. That was the angle here that we found at 180, 71, my apologies, 71 degrees. That one was 71 here. That makes this 71 here. We can now find this obtuse angle right here. So remember, okay, here we go. 180 minus the obtuse angle. The obtuse angle, which is this 71 angle here, which is this guy right back here. Boom. Gives you an angle, there's your obtuse angle, 108.98. Okay, so go back to here, 108.98. So this is 108, 108.98. Remember, that was a useless angle. We need this little angle here. So 108.98 plus the 52 now subtracted from 180. So 180 subtract 108.98 plus the original 52 gives us this tiny, tiny little angle right there. Okay, so let's boot up the calculator. 180 subtract bracket. The original one was 52, right? I hope. Yep, 52. Perfect. Whew. 52 plus this new angle we just figured out, 108, boom, gives me an angle, new angle of 19 degrees. So this top angle right up here is actually 19 degrees. Now, here we go. Ready? Back we go to the third one, right here. Remember how we wrote it out once, twice? Here's the third one. Sine of 19 degrees over that new distance, which is MT2. So 10 times the sine of 19 divided by sine 52. Whew, okay, 10 times the sine of 19. So there it is here, sine of 19, hit enter, okay, gives you a value, divided by, what was it again? The sine of 52, okay. Divided by the sine of 52. And your new distance works out to be 4.13 centimeters. So 4.13 is our MT2, 4.13 centimeters. So between those two questions, the first two podcasts were very, very long, but now I've done one question and it takes about 9-10 minutes to do. So I think this is pretty cool.